Hello, today we're going to talk about using prime factorization to find GCF and LCM. But first, let's talk about what GCF means. GCF, or greatest common factor, by definition, it is the largest factor among two or more given numbers. So for example, if I asked you to find the GCF of 24 and 40, what you could do is list all the factor pairs for 24 as well as all the factor pairs for 40. Once you have written both lists, you will see that the number 8 appears on both lists. 8 is the largest number that appears on both lists. Therefore, 8 is the greatest common factor. Now, what is LCM, or least common multiple? Well, by definition, it is the smallest number other than 0 that is a multiple of two or more given numbers. So if I asked for the LCM of 15 and 9, one strategy would be to list the first few multiples of 15, list the first few multiples of 9, and once you have come to the common multiple, the first common multiple between these two would be the smallest or the least common multiple, and in this case it is 45. Now, what is prime factorization? Prime factorization is when you have a number and that number is written as a product of its prime factors. So in order to get to a number's prime factors, you must make what we call a factor tree. So for example, we have 24, and if I ask for the prime factorization of 24, the first thing that you would do is to create a factor tree for 24. So I'm going to draw two lines which represent the branches, and I'm thinking of two numbers that when I multiply them I get 24. Well, I'm going to go with 3 and 8. Now between these two numbers, 3 is prime, so I can stop this branch and go ahead and circle the 3. However, 8 is composite, so I'm going to draw two more branches and keep breaking down 8. I could do 4 times 2 to get 8. 2 is prime, so this branch stops. However, 4 is not. 2 times 2 would give me 4. Both of these are prime. Therefore, the prime factorization for 24 we could write as 2 times 2 times 2 times 3. Again, 3 2s and 1 3. Or I can write it in what we call exponential form. We've learned that 2 times 2 times 2 is the same thing as 2 to the third power. There are no more 3's, so I'm just going to bring down times 3. Either way, we've written the prime factorization for 24. Now, using prime factorization to find GCF. There's 3 steps involved when you're trying to find the GCF and you're using prime factorization. First is to find the prime factorization for each given number. So if we look in this example, we have two numbers, 30 and 48. So the first thing I'm going to do is make a factor tree for 30. 5 is prime, 3 is not. So my prime factorization for 30 would be 2 times 3 times 5. Now I'm going to make another factor tree for 48. 48 is composite, so that's 6 and 8, 4 and 2, 2 and 2, and 6 can be broken down to 3 and 2. So the prime factorization for 48, I'm just going to write that here is 2 times 2 times 2 times 2 times 3. So that's the first step. Next step is to identify the common factors, meaning you're going to look at both prime factorizations and identify what they have in common. Well, I see 2, and I also see 3 in both prime factorizations. So what they have in common is the prime factor of 2 and the prime factor of 3. Last step is to multiply those common prime factors. And we all know that 2 times 3 is 6. Therefore, 6 would be considered the GCF of 30 and 48. Now, we can also use prime factorization to find the LCM of 2 or more given numbers. The steps: step number 1, find the GCF. So everything that we just did, we're going to do again with 12 and 15. So that means first you are going to draw, first you're going to draw a factor tree for 12. And write that prime factorization, 2 times 2 times 3. Now I'm going to do the same for 15. Both are prime. So that prime factorization, I'm going to come over here. Now I'll write it this way, 3 times 5. Now, you look to see what appears on both prime factorizations. Looks like it's 3. Nothing else appears. Therefore, 3 is the GCF. So I've done step 1, find the GCF. Now, step number 2, multiply that GCF by all the other prime factors. So once you found the GCF, and in this case it was 3, I'm going to multiply that 3 by this 2, and this 5. So 3 times 2, 6. 6 times 2, 12. And 12 times 5, 60. Therefore, 60 is the LCM of 12 and 15.